Welcome to C# for Crestron programming. In this video, we will be examining the purpose of properties, how to define them, and variations on their form. Properties are useful in code where access to a data point needs to be constrained. We will be starting with a C# console app.NET framework project called Properties. Here we have declared an integer variable called x. Variable declarations allow read and write access to their values, with only restrictions being based on scope, global or local, or via access modifiers. Here we will add two simple statements demonstrating how to assign to and receive the value from the variable. If we wish to control this access further, either to prevent reading or qualify writing to this variable, we use a construct known as a property. There is a shortcut that helps you get properties defined in your program. This is the speed key prop followed by two tabs. Here the structure of our property is represented. It is public, so it is accessible to any instance of this class and to any member within. The default type is unchanged as integer, and the name is myProperty, two fields that can be modified. Get and set, denoted by open and closed curly braces. There are two individual statements called the getter and the setter that allow you to modify access to the storage mechanism of this property. Because this is a statement, and there are several statements enclosed in the curly braces, we're able to add code in to validate information being put into this property or change the value or perform math on a value before it is returned from this property. For the console app project we are using, the static keyword needs to be added to any globally scoped member declarations. Static will be explained further in other videos. Here we will compare the behavior of the property to the original variable. This is the shortened or compact form of a property which you will see most often. The full form includes what is known as a privately scoped backing field. I will demonstrate the full form of a property with changes to the setter here. First, we will declare a backing field to store our data in a private scope. That way it is not accessible from anywhere outside of this class. Now we declare our property. Here is our public int working property with its default getter and setter. I'm going to expand the getter and setter to allow for more code. Each one of these statements is terminated by a semicolon. If we do want to add more code, we know that sets of code or sets of statements are encapsulated in curly braces, so we need to replace these semicolons with curly braces. Now, the get still shows the error that not all code paths return a value. We need to do this. Under the get, if someone asks for the value of a working property, for instance, if y equals working property, we will need to send a value back to the caller. We will return the value of hidden, our private storage mechanism, for this data. For certain data types, we could potentially return null, or simply remove the get statement to provide write-only access to the property. As far as allowing someone to assign a value to working property, as in working property equals 8, we would first like to validate the range of data that is being entered. It's going to look a little like this. Use of the keyword value. Value is a container for what's happening with working property. In that other class, if it's passing a value into this property, the value is stored in a special container with the keyword of value. That 8, as in working property equals 8, will be contained within value. So here we evaluate if it is within 1 and 10, and if so, assign our secret storage container that value. Otherwise, do not assign it. Alternately, we could have removed the set statement altogether to provide only read access to the property. You see, the final assignment of working properly equals 22 was never assigned because it is outside of the validation range. Now this is one form, an explicitly long form including a private backing field, customized get and set routines. You will see a variety of forms of properties out there in the wild. One of them uses this syntax: equal greater than to hidden. A common form is using an upper/lower case version of the property name to differentiate between the public property and private storage fields. Looking back at our initial declaration for static public int, my property, this is referred to as an auto-implemented property, and whenever this simplified type of property is declared, under the hood there is an implicit private storage location for these public properties. You have now learned about various structures of a property, how to modify the get and set statements to validate incoming data or provide read or write only access to a data point. Thank you for watching.